recursion?
It's a function that is called by itself.
Oh, yeah, that's good. At least you have that much idea. Then I don't have any problem to explain. Make okay. Well, recursion is nothing but calling function by itself. So the main advantage of recursion is we can make a very simple, okay, very complex problem. We can make it as a very simple problem. So that is the advantage. So consider it's a quite complex. There is a story behind this. The Tower of Hanoi. Okay, all of you done in the lab. Then you don't feel very difficult. The Tower of Hanoi. Okay, how we are going to do it? It's very simple. The simple rule will be there. So simple rule will be there. Okay, we need to transfer all the lead into the other lead, other axle without, okay, but the condition is that when you are transferring, it should not be bigger. Okay, bigger should not come on the top. Uh, then then it's illegal. So if recursion, that problem, if you want to solve in the normal way, it is very difficult. It is not so easy. If you want to make the same problem solution in the normal programming method, other than the recursion method, it is quite difficult. It will become very lengthy and a lot of problems we need to address. But if you make that problem by using a recursion, it will become very easy. Okay, it's a, we are making the problem, the bigger problem, into a small set of the same problem itself. Then we can easily make that solution will become more robust and more easy. So if you see in the Google, you can see the definition like this. Recursion is a process of repeating items in self-similar way for assistance. For instance, when the surface of two mirrors are exactly parallel with each other. Many. Not only this, it is a Wikipedia. In other things also, they have a type of similar type of definitions. Okay. This is the actual definition. Okay, we have many definitions. Some of the definitions are very technically relevant. A problem-solving technique in which problems are solved by reducing the term to smaller problems of the same form. We call it as recursion. This is very important. The reducing them by using a smaller problems of the same form. So same problem can solve the same problem. That is what it means. Okay, in many cases we can easily find out the recursion procedure, but in many cases we cannot. Okay, that is also difficult. In some places it is very efficient. In some places it is very costly. Okay, so that is also there. So recursion is a special type of programming method or technique, so that we can easily solve the bigger tough problems. Why? Okay, if why we need to use recursion? It is having the great style. Okay, so simple. The bigger problem will become very small. So obviously, the great style. Always, what programmer insists as a efficient programmer insists is your program size should be very small and it consumes less resources. So if it is small, sometimes it consumes more resources, but most of the time it will consume less resources only. So this is having the great style. It is powerful tool. So the people will find very much difficult problems also easily solved by using this method. So this is powerful tool for the programmer. And master of control flow, okay, because we know the problem, what problem we are going to solve. The bigger problem will become smaller, the smaller, okay, get smaller. So same problem we can understand easily, okay, that is the beauty of this. So flow easily we can analyze, okay. So some of the example we see, then only we can understand more and more easily. Recursion program we just consider. Mhm. A program recursion simply means that a function will call itself. Okay, according to definition, according to the Google definition, if you go, the program recursion simply means that the function will call itself. Main is a function. All of you will accept. If you call main function inside one more main function, then what happens? It's a terrible example for to crash.
Recur.
Right? Segment fault will generate because you cannot do that. It is very difficult. Okay, it is make the error construct the program and it will breaks. So this is not possible. This is not possible. Main supposed to call itself, but we do write the program. What happens? You just try and tell me. uh. So recursion in real life. Okay, how we can how to solve a jigsaw puzzle recursively. All of you aware of jigsaw puzzle? I believe all of you know. There is last time I shown, I think,
Yeah,
right?
sure.
Yeah. Jigsaw puzzle joining the pieces. The all pieces are same kind. You can see, right? It will generate one image. Okay, when you generate properly, when you attach properly, you will get the clear image. Otherwise, somewhere and all, it will be missing. If one piece also not correct, then the image will not be proper. Okay, that is what jigsaw puzzle. If that puzzle, okay, if that puzzle is seeing, that is what recursion, right? See, all are similar kind of pieces. We are joining together, and we are making the bigger pieces are same kind. You can see the many pieces are having the same kind of. So in the same manner, we are going to solve the recursion problems. Uh, so okay, okay, we don't go that one. That is very difficult. Recursion in real life, you can in many. Okay, just take example of your student sitting in the straight forward in the row wise, sorry, column wise, straight column. One person can see in front of the front person and back person. They cannot see the second die. So at that time, how we can able to solve? I will ask my behind person to tell me how many members are there. He will tell one plus me. Okay, then I will add it and one. How many are there? He will ask him how many are there, and he will give the count. So if we add all those things together, then we will get the number of people in that line. Okay? In the same manner, we can calculate our the entire strength, college school strength, sorry, class strength easily. Okay, that is what recursive problem in real life. Okay, we need to think of some of the real world problem, then I can easily understand the programming problem. Okay, so okay, see, this is the procedure. How to see that count the number of student in the class. The first person look behind them and sees if there is a person there. If not, the person responds to zero. If there is a person, repeat the step one and wait for the response. Once person receives a response, they add one for the person behind them and they respond to the person that asked the same thing. Okay. This is how it happens. So easily we can sum it up and we can get the strength of the particular line. So this program, if you write, we can write like this: int number student, okay, behind student, current student. If no one behind current, return 0. Else student person behind is equal to current that get behind, return student behind person behind plus 1. Okay, this is a recursive call because the same function. See, you can see here number of student behind, number of student behind. So we are calling the same function inside that function. So it will be executed. Okay. So this is how recursive call will generate the output. The structure of a recursive person is typically like the following. Okay, recursive function will be there, and one test case for simple case. Compute the solution without recursion. Okay, first you need to check the condition that we call it as a base condition, and one more condition. If this condition fails, we have one more condition, else condition. Here, the problem will be broken down into smaller problems, and we will call the recursive function. And each problem resembles the result of the sub programs. Okay, so that way we are going to deal with the recursion in C. Every recursive involves at least two cases. Okay, one is base case and the other one is recursive case. The base case is a simple case, an occurrence that can be answered directly. The case that recursive call reduce to that. Recursive case are more complex occurrences of problem that cannot be directly answered but can be described in terms of smaller concurrent of the same problems. Okay, these are the structure how we are going to implement in the C. Okay, first base case and recursive case. We need to deal with these two so that we can easily solve the recursive problem. We take one condition, number of students behind. This part we call it as a base case, and this part we call it as a recursive case. This is recursive call. Uh, we must have a three rules for creating a recursion. Your code must have the case for all valid inputs. That is very important. The case should be there for every valid input. If 0 to 10, the inputs ranges from 0 to 10, 0 to 100, 0 to 1000. For all the thousand or lakh input what you are going to supply, for all those things you should have some valid case. That is very important. You must have a base case that makes no recursive call. Okay, that is also very important. Base case, without a base case, a recursive function is go to unlimited looping, so that it will crash when the system start uh, overflow. When you make a recursive call, it should be a simple instances make forward progress towards the base case. Okay, so that it should be a some progress. If without progress, if you make a recursive call, it's a waste. So it will be in the continuous. So it is a waste. So these are the three master rules we must adopt when we are dealing with this recursive problem. One more example we can work out. Uh, power of a function. Power. If you want to find out the power, we need to write a recursive function that takes the number of x and exponent n, returns the result of x. Okay, so x power n. Okay, x power n will x power n will return the value power of x. Okay, so that is what we are going to write now. Okay, is there any recursion here? We need to see, is there any recursion? See, base condition, it's ready. If x power is 0, then it is 1. If x power is n, then it is x into x power n minus 1. Is there a recursive? The same problem, right? X power n, we are dealing with x power n minus 1. We are multiplying. The same thing happens when we are dealing with the powers. Okay, here we can see very clearly. We can make out the recursive, uh, recursive things here. So base condition, recursive condition, or case, base case and recursive case here. So each previous call wait for each previous call waits for the next call to finish. Okay, previous call first 5 3. Okay, first just like the function printf percentage d n. What happens? You know, no, right? I don't want to explain all those things. Power of 5 3. Here, which one is x? Which one is 3? Which one is n? Power is 5, 5 power 3. Okay, the meaning of this is 5 power 3. So 5 into 5 into 5 we are supposed to calculate. So first call 5 and 3, it will call again this one, again it will call this one, again this will call this one. When this calls x minus x, okay, x will be the remain, x, n will become 0, right? So when n becomes 0, it returns 1. Okay, so it will be returns 1. Here also it returns 1 into 1 into x. So here x will remain x into x, x into x. So it will x is 5 here. So 5, 5 into 5 into 5, it will be 125. So returns equals, okay, it will work out in the same manner. It will work out. So it will become the answer 125. So this is what recursive function mean. Okay, so very easily we solve. If you want to write x power n in normal programming, you try. Okay, I don't discourage you people. You just try. What are the requirement for if you want to write? And for loop is enough, and you can. This is how this program is looking comparatively that one. How length reduce drastically in this programming concept. That is what we need to know here. So this is how the size of the program become many lines, maximum 1 2 3 4 4 lines. It is completed the entire procedure. Next one, the complete example, power index. Okay, normal program you can see here, int x and y, power of int x and y, exponent is equal to 0, base case return 1, else exponent percentage 2 is equal to 1. What it means? Exponent division 2 is equal to 1, return x into power of x, else we are making the two different conditions for odd number of exponent and even number of exponent for the sake of uh, big O notation. Okay, O long n. Okay, if you write like this, it will be order of log n. Here it is big O will be order of log n. Otherwise, it will be exponent. So I can see what is the answer for this mystery recursion. My mystery n. If you said 9, it is right. See, you can see recursion returns 9, 9. Okay. Okay, this is on mystery recursion, how it returns 9. We cannot trace out in this case. Okay, you just try. Okay, these are the programs. I will upload this document so that you can try this one, and you need to see. Then only you can understand the enjoyment of the programming. Okay. Next one more recursive example we can work out. We are checking whether a given string is a palindrome or not. Okay, it is very simple. Okay, so you know what is palindrome, madam? Is a palindrome because if you read from beginning or from the end, it will give the same pronunciation as well as same spelling. Racer, race car, and race car. Okay, if you read both the direction, it will give the same word. Step on, no pets. Step on, no pets. Okay, again, it is also I will say Java false. Okay, this is how I need to get it. We need to write a recursive program for this. First, what we need to case for all valid inputs. You must have the base case, recursion call, and all those things. Uh, okay, Boolean method. Boolean is the method we can use. Is palindrome, constant string, and we are supplying string along with that. If length of the string is less than 2, the base case return true. Because if A is either if you read any direction, it will be giving A only. So if it length, we need to specify. If it is more than 2, then only we need to check the recursive call. Return true. Else, we need to call the same function. If s of 0 is not equal to s of length minus 1, then return false. This is also come under base condition. Recursive case, string substring is that string 1 comma s comma that length minus 2. Return is palindrome middle. Okay. So this is how we are going to solve this. Okay, this problem we already come across. This require. Okay, here the problem is the ABC is a spindle, and we have a tower. Then A to B. We need to transfer this all disk into the C. So because it is more than 1, so we need to use the intermediate. So first we are going to transfer. Okay, that to Tower of Hanoi problem. We can break the entire process down into very simple steps. Not necessarily easy to think of steps, but simple ones. So step 1, move the 4 smaller disks from spindle A to spindle B. Step 2, move the blue disk from spindle A to spindle C. Move the 4 small disks from spindle B to spindle C. This is the procedure what we need to do. Repeat these steps at each stage. So you can easily get it. Then break the problem into smaller sub problems of the same function again in that small form. Okay, because I'm not included the program because already we learned in the lab classes. super powerful programming tool. We learned always the perfect choice, but often a good one. Some beautiful problems are solved recursively. There must be a must for recursion. The code must have a case for all the valid inputs. You must have base case that makes no recursive call. When you make a recursive call, it should be a simpler instances and make forward progress towards the base case. Okay, this is how the three rules you need to follow when they are writing. Uh, okay, next one more problem we can deal. Okay, binary. Okay, converting binary. I don't think it is needed for you, but still. A recursion about solving the small piece of a large problem. What is the 69743 in binary? We need to find out 69743 in binary. We converting a decimal number into binary. That is what the program means. Okay, that is also a recursive way of solving it. Do we know anything about its presentation in the binary? Okay, case analysis. Uh, Suppose we are examining arbitrary integer n. The procedure is n binary representation is like this. N divided by 2 binary representation is this. N percentage to binary representation is 1. You can infer from this relate. So converting binary, the print the binary is a recursive call. We are going to make it int n. If n is less than 2, base case uh, is print d. Okay, if this is the condition, just directly print the d less than 2. That is 1. Else, recursive case, break the number apart. Print binary n percentage to n divided by 2. N divided by 2 and n percentage to. So it will give the resultant. If you have any question, you can ask me now. Okay,